The Tesla new amazing battery technology is here. Through its collaborations with several battery manufacturers such as Panasonic, LG, and CATL, Tesla has become one of the largest buyers of batteries in the world. As the demand for electric cars and energy storage continues to climb, it is highly improbable that their never-ending need for more cells will be satisfied anytime in the near future. Tesla has been hard at work on a wide range of initiatives to advance battery technology to the next level in order to meet their target of producing 3 TWh annually by the year 2030, as was disclosed during the company's keynote address at their annual Battery Day event. The fact that Tesla's new tabless 4680 battery will be made in-house by the firm itself is one of the most interesting parts of the situation. Let's take a look at some of the things that make the 4680 so interesting, as well as the reasons why going tabless is such a huge deal. When it comes to electric car manufacturers, Tesla is fairly unique in the sense that they have steadfastly adhered to the use of cylindrical cells in their battery packs, whereas the majority of other manufacturers have opted for prismatic designs. After beginning with the time-honored 18650 battery, which is widely used by producers of laptops and makers of flashlights, Tesla eventually moved on to employ larger 21700 batteries. The larger form factor meant that each cell had a greater capacity because of the larger size. Long, thin sheets of anode and cathode material are layered on top of each other with a separator material in between and then rolled up like a jelly roll to fit into the cylindrical body of the cell. This is how the cells are constructed. Each of the anode and cathode sheets has a small tab that is often located in the middle of the rolled-up sheets. This tab is responsible for transferring electricity to the terminals that are located on the outside case of the battery. These little tabs can be used to hold back cylindrical cells in a variety of different ways. They act as a bottleneck for current flowing into and out of the cell because despite the enormous surface area of the anode and cathode, all current flowing into and out of the battery must go through a pair of tabs that are only a few millimeters wide. This means that the anode and cathode actually act as a bottleneck for the current. Electrons that originate from the jelly roll's periphery have to travel quite a distance in order to reach the cell terminal. Since the length of the cell's electrical channel can be as much as 250 millimeters in 21700 cells. Because of this longer path length, there will be an increase in resistance, which will have an impact on the thermal performance. In addition, the tabs make it difficult to successfully create anode and cathode sheets at a high rate of speed since the production gear needs to repeatedly stop and start in order to deal with the protruding features. This makes it difficult to meet demands for the sheets. Prior to this, Tesla had improved its performance by switching from 18650 cells to the larger 21700 design. However, the company's attempts to further increase cell size were unsuccessful and they reached a wall. Thermal difficulties meant that charge times and discharge rates would be significantly impacted, despite the fact that larger cells can store more energy and give cost reductions in production. Because of the higher resistance caused by the longer route lengths, larger cells resulted in a lower power output per cell and a more gradual charging process. Many people believe that electric cars still charge at too slow of a rate, regardless of Tesla's rapid charging technology, hence this was a compromise that was not worth making. The tabless batteries are now in use. Instead of having a small battery tab attached to the anode and cathode respectively, the entire anode and cathode foils are laser patterned and processed to have what are essentially many tiny tabs all along their length. This is done rather than having a small battery tab attached to the anode and cathode respectively. This eliminates the need for further steps in the production process that involve manually joining different tabs. These several tiny tabs flatten out to perform a shingled spiral when the anode, cathode, and separator are all rolled up together. This results in a considerably larger contact surface being created between the active battery material and the casing. This results in a significantly shorter path length for electrons to travel. Tesla estimates that this represents a reduction to up to 5 times the length of the path compared to earlier designs. This is as a result of the fact that electrons are now able to proceed more directly towards the battery terminal as opposed to previously needing to travel to the center of the sheet first in order to reach the single-tap connection. The final product was a cell with the designation 4680, which refers to its diameter at 46 millimeters and its length at 80 millimeters. This is a deviation from the 5-digit nomenclature, but because no one at Tesla could figure out why 18650 cells have the trailing 0, the company deleted it in the new cells designation. Because of their increased dimensions, the new cells are said to be capable of storing 5 times the amount of energy as their predecessors. Even better, Tesla asserts that they are able to supply up to 6 times the power as a result of the shorter electrical channel length provided by the table-less structure, which allows for improved thermal performance. The conversion to 4680 cells in Tesla's automotive packs could result in a range boost of up to 16%, according to some estimates. This would be an outstanding amount given that the company currently has impressive numbers in this area. For instance, the forthcoming Model S Plaid, which will utilize the 4680 cells, boasts that it will have a range of 520 miles. The new design also has positive effects on the manufacturing process. The anode and cathode can be laser patterned for direct connection so that they do not require separate tabs to be attached. This allows the materials to be processed in a manner that is analogous to that of paper manufacturing, in that continuous roll processing can be utilized. The fact that the machinery will be able to move at consistently high speeds rather than needing to constantly accelerate and decelerate in order to attach tabs to each anode and cathode sheet will allow for enormous advances in production speed as a result of this development. With the production methods that are currently in use, Tesla will not be able to reach its production targets of producing more batteries to satisfy demand. Therefore, improvements in processing and production speed are essential to finding a solution to this issue. This will also contribute to cost savings, which is a big component of the company's goal to build an electric vehicle that is more accessible at the price point of $25,000. These new cells, with their higher energy density and high power output, would appeal to a large market of hackers and producers because of these characteristics. Nevertheless, the overarching message that resonated throughout Tesla's speech was that the company is simply unable to acquire enough batteries to satisfy its requirements as they stand. Since Tesla keeps its whole supply for its own internal usage, we believe that it will be several years before Tesla's tabletop batteries become available for purchase by the general public. It is likely that other manufacturers will rush to develop comparable technology as a result of the benefits that are on offer. However, this will take time, and in the meantime, individuals who are interested in obtaining the best cylindrical cells will have to wait for new Teslas to appear in their neighborhood wrecking yards. The statement concerning the tabless technology was only one part of Tesla's announcements regarding Battery Day. In order for the corporation to fulfill its lofty goals of increasing battery manufacturing to satisfy demand all around the world, work is currently being done to develop advancements in other areas such as the chemistry of the anode and cathode as well as production procedures. In order for electric transportation and Powerwall grid storage to actually alter the world, projects such as these will need to be successful. Otherwise, we won't have the batteries necessary to put in the automobiles that use electric transportation. Thank you so much for watching this video. Please make sure to like this video and subscribe to this channel for more new videos.